Hello, welcome to Old School Chemistry. Let's talk about oxoacids. Here is your huge takeaway. The more oxygens you have in the acid, the stronger the acid. Now remember, what drives strength of acid is right down here. The more easily and completely an acid ionizes, breaks apart, the stronger that acid is. A strong acid will 100% break apart, 100% ionize. So here's a great example for you. We're going to look at nitric acid and nitrous acid. The nitric acid is going to be a stronger acid because it has 3 oxygens, and the nitrous acid only has 2. So that is a weak acid. It only partially ionizes and breaks apart, whereas the nitric acid 100% does. Now this is for 2 reasons. The most important reason has to do with here we have it, electron attachment enthalpy, okay? So the more oxygens you have, the less negative that electron attachment enthalpy. Now you can think in your head either electronegativity or electron affinity. This is the ability to attract electrons to itself. The more oxygens you have, the less ability that that particular acid has to attract electrons to itself. Now the justification, the great big because, all right, why is that true? It's because the more oxygens you have, the more stable the anion. When this ionizes, you're going to have the hydrogen ion and the nitrate ion. Okay, let me write that down actually. You're going to have your H plus and the NO3 minus. Because you have 3 of those oxygens, that anion is going to be more stable than the nitrite ion, the NO2 minus. The reason being is that there are more atoms for that negative charge to disperse, which creates and increases stability. Now the second reason, it has to do with bond strength. And simply said, the more oxygens you have, the weaker the bond strength between that hydrogen and its bond. So it's easier to ionize and break apart the hydrogen from the anion. Now I want to take just a second to contrast. We have hydrogen halide acids like hydrochloric acid, hydrofluoric acid. I will link up above that you can look at those. Those have the same true justifications where you're looking at that electron attachment enthalpy and the bond strength. Interesting. On our hydrogen halides, the most important thing is bond strength, but in oxoacids, the most important thing is actually the electron attachment. The less negative, the less ability to attract electrons, the greater the strength of the acid. Big, let's put this all in perspective. A strong acid is more easily ionized. It breaks apart much easier. A strong acid will 100% ionize, 100% break apart. And so you're thinking, okay, what's the easiest way for that to happen? And in this case with the oxoacids, the more oxygens you have, the greater the ability for that to ionize and break apart. Nice. Again, take a look at the hydrogen halide if you have questions on that. Thank you. Subscribe and like. Great to see you.